you already learned about the normal mode. Okay, so for the timer programming, okay, in order to generate a delay, we have two modes available. One we call it as a normal mode, and the second one we call it as a CTC mode. Okay, for the normal mode, the other name for the normal mode is a overflow method. Okay, so now we are going to see the step how to write a program in order to create a delay for normal mode method. Okay, so this is the step that you need to know. Okay, so I just summarize this step here. Okay, first, okay, so we just open a new file. Okay, so here is a normal mode. And let's look at what are the steps that you need to take in order to write a timer programming for the normal mode. Okay, first, what you need to do is you need to load the TCNT value. Okay, in order to load a TCNT value, okay, what you need to do before that is you need to calculate the TCNT value based on the three equations that I gave you earlier. All right, so the first equation that you need to know is, okay, before you proceed with the, okay, to load the TCNT, what you need to do is you need to calculate the TCNT. Once you calculated the TCNT, then after that you can do this programming. Okay, the first step here. Okay, so first equation that you need to use here is T equal to 1 over F, in which T is your period and F is your external speed or your CPU speed. Okay, and then the third equation, okay, that you need to remember here is delay equal to, okay, T multiply with count. Okay, usually we already know the delay. Okay, you already know that what are the delay that you're going to generate, and then from equation 1 you can obtain T. So now what happened here, you will get what is the count value. Okay, after you get the count value, then after that you can put it on the third, what we call here, the third equation here, which is TCNT equal to FF, okay, because the size of the TCNT is 8-bit, so the maximum number is FF or 255, okay, minus with count, okay, so this count value you get in the second equation plus with 1. So now you already obtained the TCNT value. And after you obtain the TCNT value, then you put it inside of this step 1 here. Okay, so this is the step 1, okay, to do a C programming, okay, for the normal mode timer programming. Okay, then step number 2, okay, after you load the TCNT, then after that you're going to set your TCCR. Okay, do some setting on your TCCR register. So inside of this TCCR register, you can do two settings, okay, as I mentioned earlier, okay, in the last week, okay, where you can choose the mode, okay, of the timer mode. You're going to choose either you're going to use a normal mode or CTC mode. Okay, so here you can put it, okay, do the setting inside of the TCCR as well as the pre-scaler. Okay, so you can choose what are your pre-scale value. Okay, so remember, okay, recall back for the normal mode and for the TCCR, okay, especially the TTCR, okay, so you have 8 bits of TCCR, okay, so you need to remember lah, okay, what bits that you need to set, okay, so the first one here is bit 3 and bit 6, okay, so this bit 3 and bit 6 here is used to determine the mode. Okay, so if you put 0, 0 on this bit here, what happened? Okay, you're going to use the normal mode. Okay, if you put 0, 1, then this is a CTC mode. Okay, you're choosing a CTC mode. And next, the last 3 bit here. Okay, so this is another important bit that you need to set. Okay, do some setting. So this is what we call as your pre-scale. Okay, so there are a lot of value here. Okay, a combination of value started from 0, 0, 0, which is you're going to stop your timer. Okay, so 0, 0, 0, stop timer. And then 0, 0, 1, okay, no pre-scale. And you have a 0, 1, 0. Okay, you have a pre-scale 8, and then until 1, 1, 1, 1. Okay, so that one you can refer to the table. Okay, so this pre-scale table here. Okay, where is the table? Okay, this one. All right, so you can refer to this table for this combination of input that you can put inside of these last 3 bits. Okay, then next, step number 3. Okay, what you're going to do here is you're going to monitor the TOV flags. Okay, why TOV flag? Because now you are going to use the overflow method. Okay, every time you use the overflow method, so you need to refer to TOV flag, whether your TOV equal to 1 or 0. Okay, if the overflow occurs, what happens? TOV. Okay, so here, okay, is TOV equal to 1, okay, and TOV equal to 0. Okay, so if the TOV equal to 0, what happens? Means that the overflow is not occurs. Okay, means that you need to keep monitoring the flags. And when the TOV equal to 1, okay, so what you're going to do here, you need to exit from this monitor loops. Okay, so in order to do this monitoring, you need to create a loops, a while loops. Okay, later we will see how to create this while loop to monitor the TOV flags. Okay, so that is step number 3, and then followed by step number 4. Okay, since you already finished the TOV, okay, since the TOV equal to 1, which is the overflow already occurred, so what you're going to do now is you need to stop your timer. So how to stop your timer? Okay, by setting the TCCR. Okay, you see here on the pre-scale, when you put 0, 0, 0 here, you're going to stop timer. So by default, okay, to stop timer, okay, you can write this code here. Okay, so this is the standard code lah. Okay, so TCCR. Okay, for example, if you use a timer 0, okay, so TCCR 0 equal to 0. Okay, so this is the default. To stop timers, you just put this value here. Okay, means that the value that you put to your TCCR is 0, 0, 0, 0, 0, 0, 0, and 0. Okay, so now you're going to stop the timer. And then step number 5, okay, after you stop the timer, since now, okay, the TOV flag equal to 1. Okay, so now if you're going to do the what we call here to create another delay, so you need to make sure that this TOV flag is reset. So how to do that? Okay, later we will see how to clear the TOV flag. Okay, so here is you're going to clear the TOV flags. And step number 6, okay, since this is a normal mode, okay, as I mentioned earlier, the normal mode, okay, is to generate one sequence of a delay. Okay, only one delay will be generated. If you're going to generate a delay periodically, so what you're going to do here is you need to ulang or repeat step number 1. Okay, load again the value TCNT, do the settings, monitor TOV, stop timer, and clear TOV. So this is the things, okay, you're going to do in order to do a normal mode timer programming. Okay, any question up until here? Ada soalan tak? Okay, if no question, okay, so let's look at the next slide. I need to minimize first and then go back. Okay. Okay, so this is the summarize lah. Okay, what I did earlier is a summarize on how to program timer zero in normal. Okay, so now let's look at these examples. Okay, so given this, okay, you are given this program. Okay, so what this program do here is this program creating a square wave. Okay, it's going to create a square wave. Okay, creating a square wave. Okay, 50% duty cycle with equal portion and high-low on the port B pin number 5. Okay, means that, okay, you have a, this is your Atmega 32. And this is your port, this is a port B pin number 5. Okay, so you have a pin out here. Okay, and then from this port B pin number 5, what happened? You're going to create a square wave. Okay, so this is your square wave. Okay, and it's telling you, okay, the square wave duty cycle is 50%, that it equals portion high and low. Okay, so this is one clock cycle. Okay, so this is one cycle. Okay, and then you know that the duty cycle is 50% for high and another 50% for low. Means that the, okay, so this is your, okay, and this is time lah. Okay, so means that the duration for, okay, taken for the logic 1 and logic 0 are equal. Okay, so in this example, timer 0 is used to generate the time delay. Okay, now you're going to analyze the program. Okay, so let's see line by lines what this program do. Okay, first this is the basics lah. Okay, this is the mask. Okay, which is you need to include the avr/io.h header. Okay, and then after that, okay, you need to, so this is you, what you going to do is here is you need to declare the subroutine. Okay, so this is the subroutine, okay, name T0 delay. Okay, so since you have a one subroutine, so this is your the subroutine, so you need to declare above here. If not, the microprocessor will not what we call here, will not recognize this subroutine. So you need to initialize or declare the subroutine after you put your header. Okay, and then after that, okay, you start with your main program. Okay, so this is your main program. Inside of this main program, okay, what you're going to write here is you need to initialize your port B as a output port. Why output port? Because this port B5 is producing the square wave. Okay, so now you're going to initialize the port B as a output port. Okay, so okay, so this is we already always we already done this many times. Okay, so I just make it quick on this side here. Okay, and then after that, okay, since this one here, okay, it will started with 0 lah, port B equal to 0. Okay, you're going to start your square wave with 0, and then what else? Do you have any other ports to initialize? No. Okay, no other ports. Only port B pin number 5 need to initialize as a output port. Other than that, you not use other ports. Okay, for this program. Okay, then after that, okay, you create a while loop. Why while loop? Because you're going to create this square wave endlessly. Okay, which is a forever. Okay, so that's why we use this while loop. And under this while loop, okay, what you're going to do here is you need to generate, okay, to create a toggling process. Okay, so this is the toggle process, which is, okay, first it will generate logic level 0, and the next cycle it will generate logic 1, and after that logic 0 again, logic 1. So this is a toggling process. So this toggling process is used for to create the square wave. Okay, so Now, so this is how to do a toggling process lah. Okay, port B equal to port B. Okay, because initially, okay, we initialize the port B equal to 0. Now, you going to do the exclusive OR. Okay, so this symbol here is exclusive OR. Okay, in which now this is actually equal to this one lah. Okay, port B sama dengan port B. Okay, do exclusive OR with 0B00100000. Okay, which is you're going to toggle pin number 5 only. Other than that, okay, no need to do anything. Okay, so that's why you toggle with this value. Okay, and then after you toggling, okay, after you toggle that port B pin number 5, what you're going to do here, you're going to create, okay, you're going to call the delay. Okay, why to call the delay? Because you're going to this one here. Okay, because this is one cycle of the square wave. Okay, and then the portion here for the logic 1 and logic 0 is equal, so you need to create to call a delay in order to generate or in order to create this what you call here this time, okay, duration of logic 1 and logic 0. Okay, and this is your main program. Okay, so now what I'm going to focus now on this section here, which is your timer programming. Okay, so this is the timer programming subroutine. Okay, so void to delay. So this void to delay. Okay, so this name here must equal to what you already declare here lah. If you put others name, for example, void delay 100 seconds. So this one you also need to void delay 100 seconds. Okay, so these two must be the same name. Okay, identical name. And then open curly bracket and close curly bracket. And after that, all right, so after that, okay, now you're going to see this thing here. Okay. All right. So now, okay, TCNT0 equal to OXF2. What you're going to do here, okay, means that this is the first step, okay? You're going to load, okay, no, not this one. Okay, so this is the actually your first step, which is you're going to load the TCNT value. Okay, so how to load this TCNT value based on this calculation? Okay, later you will see lah. Okay, what are the number that you're going to put here? Okay, so based on this equation here. Okay, and then TCCR0 equal to OX01. Okay, so this is your second step, which is you're going to set your TCCR. Okay, so since this one here is, okay, when you look at these numbers here, 0, 1, okay, so you can, okay, you can figure out what are the, what we call here, the setting that you put it inside of this program. Okay, so this is, okay, the value is 0, 1. So 0, 1 is actually 0, 0, 0, 0, and then 0, 0, 0, 1. Okay, now we're going to check what are the setting, okay, this program do. Okay, so bit 6 and bit 3. Okay, 0, 0 means that this is a normal mode. And then next, okay, we're going to check this last 3 bit, 0, 0, 1. Okay, and from here, 0, 0, 1, there are no prescale. Okay, no prescale use. And one more thing, okay, you see here, TCCR0, TCNT0. So now you know that, okay, so this is a timer 0. Okay, so now you can conclude that, okay, so we use a timer 0 normal mode with no prescale based off according to this number that you put, okay, inside of this TCCR0 register. Okay, so far, any question up to here?
No, Doctor.
Okay,
Doctor?
Yeah.
Please, when do we need to initialize and prescale? Like
Okay.
in what situations?
Okay, so this one here, in order to initialize the prescale, let's say lah, if you're going to make a largest delay, okay, by using no prescale, you cannot achieve that to create that largest delay. So in the next slide, we will learn about how to use the prescale in order to obtain or in order to create a large delay or a big delay.
Okay.
Okay, and this is step number 2. And then step number 3, what you're going to do? You're going to monitor the TOV. So how to monitor the TOV? Okay, by using this line here, this coding here, Y, TIFR, and with, okay, so this is the numbers. Okay, so depending on what are you going to look at. Okay, since this is a timer 0, so we are going to look at TOV 0. Okay, so now how you obtain this value 0x01. So now we are going back to the TIFR register. Okay, where is TIFR register? So this is, oh no, TIFR, not this one. Oh, where is the TIFR register? Okay, this is TCCR0. Okay, this one. Okay, so this is your TIFR register. So in the example, okay, you're going to use the timer 0 overflow method. So we're going to look at this TOV0 flag. Okay, so TOV0, okay, according to this TIFR, okay, so this is the location of the TOV0, okay, on this here. Okay, so you know that. So this is actually you're going to look at, okay, 000 because, okay, and then 0001. So this is your TOV 0. So you're going to compare with this number. Okay, you're going to check whether the TOV 0 is what is already 1 or not. If not, then you keep monitoring. If yes, then you exit from the loop. So this is what happened in this third step here. Mana tadi? We are going too fast. Okay, here. Okay, this one. Okay, which is in this one here, what you're going to do here is you have a TIFR, and then you end with this value 0B00000001. Okay, because you're going to look at the TOV0 here and check whether it equal to 0 or not. Okay, if the TIFR, okay, so this is your TIFR. Okay, so this is your TIFR. Okay, if the value here is 0, so 0 and with this number, you will get 0. So what happens? It will keep monitoring because this is inside of the while loop. Okay, let's what we call here the overflow occurs. So when the overflow occurs, what happens to your TOV1? Okay, inside of the TIFR, it automatically become 1. Okay, so this is when the overflow occurs, it automatically become 1. And then when you end with this value, okay, so when you end 00001 and with this value 0001, so what happened? You no longer get 0. Okay, you will get 1. Okay, 00001. So what happened? So this while loop is now become false. Okay, the condition of the while loop become false. Now what happened? You're going to do the next step, which is stop the timer. Okay, so how to stop timer? By putting your TCCR with 0. Okay, you see TCCR 0 sama dengan 0. So now you going to stop the timer. And after you stop the timer, okay, what you're going to do, you're going to clear the TOV flags. Okay, because now your TOV flags, this is your TOV 0 flag, is 1 after the, what we call it, the overflow occurs, TOV 0 flag become 1. So now you're going to clear this one so that it becomes 0 again. So how to do that? Okay, you can use this line here. TIFR sama dengan 0x01. Okay, in order to clear, so this is the special case here. In order to clear the flags, okay, we need to put 1. Okay, not put 0. Okay, to clear a flag, you need to put 1 to your flags register. Okay, so this is the special case. Okay, so now what happens when you put this value? Okay, 0. Okay, you put 0, 0, 0, 0, 0, 0, 0, 1 to this TIFR. So what happens now? The TIFR become 0 again. Okay, you already clear your TIFR. And step number 6, okay, repeat number 1. Okay, means that repeat number 1, you need to call again this apa ni, subroutine. Okay, so this is how you going to write the C programming for normal timer to create a delay using a timer 0 normal mode method. So this is what you going to focus now. Okay, how to do this program here on this part. Okay, so this is the summarize what happened. Okay, so first you look here. Okay, first step, what happened? This value is loaded to TCNT0, and then second step, you set the settings. Okay, once you set the settings here, the timer is started. Okay, it will start counting. Okay, and then when step number 3, okay, you're going to monitor the TOV0 flags. Okay, so timer 0 count up with the pressing of each clock, which is provided by the your Esther. Okay, as this timer count up, it goes through the state of, okay, since you started with F2 and we start with F2, okay, TOV masih lagi 0. F3, TOV0 equal to 0 because there is no what we call the overflow occurs, and then it keep increasing until FF. Okay, when FF, TOV0 still equal to 0. When FF roll over from FF to 00, so now the overflow occurs here. So what happens when overflow occurs? TOV0 automatically become 1. Okay, when the TOV0 become 1, so what happens? You exit from this step number 3, and now you're going to stop the timer. Okay, once you stop the timer, okay, then after that, okay, you're going to clear the TOV0 flags. Okay, so this is the summarize what happened to this subroutine here. Okay, so now we are going to look at another examples. Okay, so in the previous example, okay, example 9.3, calculate the amount of time delay generated by the timer. Assume that the external equal to 8 MHz. Okay, so given that the external sama dengan 8 MHz. Okay, and based on this value here, okay, programming here, okay, you need to figure out what are the delay here. Okay, generate based on this value. Okay, given the value, you're going to find out what are the delay. Okay, so before that, okay, now we're going to look at these two things here. Okay, step number 1 and step number 2. Okay, from step number 2, okay, we already know that you using a timer 0, normal mode, and no prescale. Okay, this is the things lah. Okay, yang important things. Normal mode and no prescale. Okay, since this is a no prescale, so now you can apply the equation. Okay, so we have an equation here. This equation. Okay, T equal to 1 over F, and then delay times T count and so on. Okay, so the first equation here is T equal to 1 over F. Okay, so since there is no prescale, then we can use this extra as our frequency. Okay, if you have a prescale option, okay, use in your programming, so what you need to know to do here is you need to find your new F. Okay, F after your prescale equal to, okay, so this is the formula, F divided with your prescale value. Okay, actually no prescale. The prescale value is equal 1. Okay, so f divided by 1, okay, 8 megahertz divided by 1, you get the same value, 8 megahertz. Okay, so now 1 over 8 megahertz, okay, you will get 0.125 microsecond. Okay, and then step number 2, okay, what is the question for step number 2? Delay equal to t multiplied with count. Okay, you're going to find out what is the delay. Okay, you already have the t. Okay, what about count? Can you calculate the count? Yes, you can calculate the count. How? But how? Okay, according to this one here, okay, this line here, okay, TCNT0 equal to OX F2. Okay, you already know that TCNT0 sama dengan F2. Okay, so what you're going to do here, okay, from using the third equation, okay, what the third equation says, TCNT equal to FF minus count plus 1. Okay, TCNT, you have the TCNT value, which is F2. Okay, so you just masukkan lah. Okay, you just insert in this equation here, F2 equal to FF minus count plus 1. So now you can get the count. Count equal to FF minus F2 plus 1. So you get, okay, so just press the calculator. FF minus F2 and then plus with 1. Okay, so you get 0 E. Or you can change this one here to what we call here, to decimal number, which is equal to 40 times. Okay, so the number of the count that you need in order to generate this delay here is 40 times, or 14 ticks. Okay, so since you already get the count value, so now you can know what is the delay. Okay, so delay equal to t multiplied by count. T is 0.125 microsecond, multiply with 40 times, so you will get 1.75 microseconds. So this is the delay that you generate based on this program. Okay, so what is this 1.75 microsecond here? What is this delay all about? Okay, this delay here is actually your this okay, this logic 1 here, the duration of logic 1. So this is 1.75 microseconds, and this one also 1.75 microseconds. So so this logic 1 will be the duration of the logic 1 is 1.75 microsecond, and the duration of logic 0 also 1.75 microsecond. So the period, okay, the t of this square wave, okay, the period of this square wave is, okay, you can get lah, okay, 1.75 darab with 2, okay, then you will get 3.5 microsecond. So one clock cycle is 3.5 microsecond for this T wave. Okay, any question up until here? Okay, if no question, okay, so this is how to finding the value to be loaded to the timer. Okay, so this is where you're going to find out how to what are the value, the TCNT value that you need to put to your timer. How to do that? Okay, by using these three formula. Okay, so by applying these three formula, that you can know what are the value that you're going to put inside of your TCNT. Okay, so let's look at the another examples. Okay, so this one here. Okay, assuming that the X-Stel is 8 MHz. Okay, again, given that the X-Stel sama dengan 8 MHz. And you are going to write a program to generate a square wave with a period of, Okay, dia bagi tahu kat situ. Okay, so you have a ATmega 32 and you have a port B pin number 3, and this port B pin number 3 will generate this square wave, and it says that this square wave have a period of 12.5 microsecond. Okay, so this is the period. Okay, so you have two period here. Okay, one for the clock, your CPU speed. Okay, you have T equal to 1 over F. So this is your T clock, the T for the CPU. But this one here, the period 12.5 microsecond is belong to the period of your square wave. Okay, the T wave is 12.5 microseconds. Okay, so based on this information, you're going to write the program. Okay, write a program. Okay, let's assume that, no prescale is used, no prescale, and using a normal mode. Okay, so what are you going to do? Okay, first, we can use the first, equation, which is T sama dengan 1 over F. Okay, so this is the first equation here. Since T equal to 1 over F, you can find out what are the period of your frequency, your external speed, your CPU speed. Okay, since you are not using the prescale, so you can divide it 1 over 8 megahertz. Okay, so you get 0.125 microseconds. Okay, and then number 2, what is the equation number 2? Delay equal to T multiplied with count. Okay, now you're going to find out what is your count. Okay, can you get the delay? Okay, from this information, can you obtain the delay that you're going to generate? Okay, you already calculate the T, and can you calculate the obtain what is the delay value? Boleh tak dapatkan delay value from this information? Anyone? Okay, yes, you can obtain.
Doctor.
Okay, yes, you can obtain the delay. How to obtain the delay? Based on this period of your square wave. Okay, since this is a square wave and it have a same portion, which is 50% duty cycle for logic 1 and another 50% logic duty cycle for logic 0. So according to this, since this is your period, okay, so you can divide this number here with 2. Okay, so 12.5 divided by 2, okay, you will get 6.25 microsecond each. Okay, so this is actually your delay. Okay, so let's look back at the previous example. Okay, the one that we all calculated here, okay, the 1.7 millisecond. Okay, so the 1.7 millisecond is actually, where is, okay, here. Okay, 1.75 millisecond is actually this things here. Okay, the duration for the logic 1 and duration of logic 0. So this is actually the delay that you're going to generate. Okay, similar to this one lah. Okay, so the 6.25 actually the delay. Okay, so this is your delay. So based on this information here, okay, you can get count equal to delay 6.25 microsecond divided with T 0.125 microseconds, then you will get berapa you get? Can you press the calculator? Okay, you get 50 times. Okay, 50 kali. Okay, the total count is 50 times or 50 clicks or ticks of your clocks. Okay, then next step number 3. After that, you can calculate what is your TCNT, which is TCNT equal to FF minus count plus 1. Okay, so this FF here, okay, you can change it to decimal number, which is 2, FF is 255, minus count, what are your count? 50, plus 1, and you will get 206. Okay, you can change back this 206 to what we call here hexadecimal, which is CE. Okay, now we are going to write the program. Okay, so we're going to write the program. Okay, so this part here, I just skip this part, okay, which is you include the file and then do the main program. Okay, so this part here, I assume that all of you already know how to initialize the port B, how to create the toggling process here. Okay, the toggling wave, the square wave, okay, by using the toggle function, okay, the toggle coding here. Okay, so now I'm going to focus on this side, okay, which is to program the timer 0 using a normal mode. Okay, so let's this one here. Okay, so we started with what we call here, okay, the delay subroutine. Let's the name here is void delay. Okay, delay T0, for example. Okay, so this is the name of the subroutine. Okay, and then okay. Okay, then you open curly bracket, and then after that, close curly bracket down here. Okay, so under the subroutine of the delay programming, okay, so what are you going to do? Okay, first step, what is the first step? Anyone? What is the first step that you're going to do? Siapa nak tolong ni? Okay, what is the first step? First step is you need to load the TCNT value. Okay, since this one here, we're using the timer 0. Okay, so what happened to my pen? Okay, so TCNT0 equal to what value that you're going to put to your TCNT0. Okay, based on the calculation, okay, this is the value that you're going to put to your TCNT0 or to load to your TCNT. Okay, so 0xCE. So this is the first step. Okay, what is the second step? The second step here is you're going to do the setting. Okay, so TCCR0. Okay, and what are the value that you're going to put inside of your TCCR0? Okay, so again, okay, we draw our TCCR0. So this is a TCCR0. Okay, what are the things that you're going to put inside of this TCCR0? Okay, so this bit 6 and bit 3 indicates the mode that you're going to use. Okay, since this one here, we're going to use a normal mode. So going to put 0, 0 here. And then after that, okay, what happened to my pen? Not recognized. Okay, then after that, okay, this bit here, the last 3 bit, okay, is used to select the pre-scale. Okay, since this example here, we are not using the pre-scale. Okay, so what is the value that you're going to put here? The value you're going to put here is 0, 0, 1. Okay, normal mode without pre-scale. So this is the value that you're going to put here, which is 0, 0, 0, 0, followed by 0, 0, 0, 1. Okay, so I just make a box here. So these are the things that you need to set. Okay, so this is normal mode, no pre-scale. Okay, step number 3. What is step number 3? Okay, you're going to monitor the TOV flags. Okay, so Y. Okay, so TIFR. And with what number? Okay, since the TOV flags, okay, so this is your TIFR, is located at this bit. Okay, so this is your TOV0 flags. Okay, we are going to use a timer 0, and this is our overflow method, normal mode. So we're going to look at this bit here, okay, which is at bit number 0. So that's why we put the 0x0, 1. Okay, the value here. Okay, is it equal with 1? Sorry, 0? Okay, if yes, it will keep repeating. If no, then it will exit from this loop. Okay, so actually, okay, this one here, okay, sometime, okay, you can change this writing, okay, to more fancy way, okay, which is you can put it something like this. Okay, Y TIFR, and with, okay, this one I already tell you in the previous class. Okay, put 1 to the location of TOV0. Okay, you can do something like this. Also can. Okay, sama dengan kosong. Okay, if you put something like this, so no need to know lah the location of your TIFR registers. Okay, so you only use the names. Okay, the label, the names of the flags that you're going to use. Okay, then after that, step number 3 finish. Step number 4, okay, stop the timer. How to stop the timer? Simply put 0 to your TCCR 0. So this is step number 4. And what about step number 5? Step number 5, okay, you need to clear your TOV0 flag. How to clear the TOV flag? By putting this value, okay, the same value that you check in the monitor in the step number 3. So 0x0, 1. Or sometime, or you can simply write something like this: TIFR equal to put 1 or shift 1 to the location pointed by TOV0. Okay, so this is the thing. Okay, so this is the program. Okay, in order to generate a 6.25 microsecond delay by using timer 0, no prescale, and normal mode. Okay, so I just going to highlight where is the location that you're going to. So this is the basic templates lah. Okay, every time you're going to do a programming for the timer programming. So this is the template that you're going to follow. Okay, the things that you're going to change here is step 1, this value according to your calculation. Okay, for the TCCR, okay, these things are, okay, this value you're going to change. Okay, either you're going to use a normal mode or prescale. And for the while loop to monitor, okay, you're going to change this value only. Okay, the what we call here, the flag that you're going to monitor. Step number 4, same. Okay, copy the same coding. While step number 5, this value. Okay, you're going to change this value according to what are the flags that you're going to monitor. That's it. Any question? Okay, if no question, we're going to stop here. Okay, next week we are going to looking at the how to generate a large time delay by using a prescaler option. Okay, any question from you?
So I want to ask the extra. If you want to simulate in the AVR Studio, then how are we going to know the extra frequency? Is it when we are going to connect a oscillator to the extra pin?
Okay, the extra is you can simply, okay, for the AVR, okay, you can simply what we call here, declare your extra frequency. Okay, by using the define f underscore CPU. So what is the extra speed that you're going to use?
Okay, thank you, sir.
Okay.
And Doctor,
Yeah.
regarding the servo segment, since it is not possible to display K, should we skip it or
Display K.
yeah,
Okay, because for the K, this is for the metric numbers, correct?
yes,
Because your metric number contain the K value, the
yes,
K character. So for the K, maybe you can put something like H.
okay.
Okay. Okay. Any other questions?
Sorry, I want to sorry, sir, just now I want to ask when is the test 2, the date? Is it on 15?
Okay, the test 2, okay, we already decided last week on 20th. Is it 20? Betul ke?
16th.
20. That's the date.
Yeah, 20.
Yeah.
Okay, Sunday, 20th June. Okay, so this is the date for the test 2. Okay, any other questions?